Aspartame is an artificial sweetener containing two amino acids, aspartic acid and phenylalanine. It is a methyl ester that is not very heat stable, so it is not recommended for use in baking and cooking, as this breaks down the compound, resulting in no sweetening effect. Aspartame is 180 to 200 times sweeter than sucrose, so a much smaller amount can be used in the products in comparison to sugar. It is used to sweeten a variety of low and reduced calorie foods and beverages, and is sold under the brand names NutraSweet, Equal, and others. There are over 6,000 products in more than 100 countries that have aspartame as a sweetener. Some examples include juices, iced tea, flavored water, chewing gum, canned fruit, tabletop sweeteners, nutrition bars, cereals, and carbonated drinks. Aspartame was first discovered in 1965. One of the ways to make aspartame involves the use of a hazardous chemical in the process called toluene. Toluene comes from crude oil, which is non-renewable and is harmful to humans. Small exposure can cause drowsiness and headaches, while high exposure can cause kidney and liver damage. In addition, this particular process ends up producing 4 different isomers. Isomers are chemical compounds that have slightly different structures and so have different properties. If 4 different products are produced, they would need to be separated, which takes energy and the use of other chemicals, which is not very efficient. But more on this later. Biocatalysis is the general term for the use of biological enzymes or cells to increase the rate of a reaction or enable a reaction to occur. Because of this, the term biocatalysis is also referred to as the application of enzymes in chemistry. Chemical transformations carried out by every living organism are enabled by thousands of proteins known as enzymes, which have catalytic activity for conversion of a particular set of substances to specific products. The industrial production of aspartame involves incorporating biocatalysis into one of its steps. In this reaction, aspartame is produced by a protease-catalyzed condensation reaction. Why use a protease as a catalyst? Protease enzymes such as thermolysin are found to be useful tools for peptide synthesis because of their high stereo and regioselectivity. The use of a protease as a catalyst does form undesirable compounds such as the beta-APM, which exhibits a bitter taste. However, this method is more selective, requires no use of the hazardous toluene, and uses water as a solvent for the enzyme to work in. To explain selectivity, imagine you have a potato. It can be transformed into different forms such as French fries, hash browns, wedges, and curly fries. If you are trying to make French fries, but you end up producing the other forms as well, then this process is said to be unselective. The biocatalysis process of making aspartame is selective, as the main product produced is your desired product, your French fries, so to speak. Green chemistry is about designing products or processes with the goal of generating as little hazardous waste as possible. It is not as much about cleaning up waste, but rather eliminating waste at the source by implementing the 12 principles of green chemistry, the most important of which is to prevent waste. Another part is to find a less wasteful method to do so, which usually involves reducing the use of solvents in a reaction. Solvents can contribute to a large proportion of waste, as they are the medium in which reactions take place, but they are not always involved in the reaction itself and is disposed of when the reaction is completed. From a green chemistry perspective, these solvents would be reused instead of disposed of. Enzymes are rarely selective catalysts, which means that they only react with reagents in a specific way to produce specific products. They also work well in water, which can replace the use of more hazardous solvents such as toluene. Reactions catalyzed by enzymes can be highly efficient and produce little byproduct in this way. The enzyme thermolysin is selective in the way it reacts and triggers the production of one specific arrangement in the product out of 4 possible arrangements. This makes the reaction very efficient, as there is a high yield of one isomer. This coincides with a few of the 12 principles of green chemistry: preventing waste, maximizing materials incorporated into the final product, and catalyzed reactions being superior. The demand of aspartame being so large as the most popular artificial sweetener in the United States, and being used in thousands of products, around 16,000 tons of aspartame is consumed every year globally. With this in mind, The use of enzymes in its production is key to reducing waste and maximizing efficiency on the industrial scale. How green aspartame itself is, however, another question. When aspartame is consumed, it is completely broken down by the enzyme in the digestive system into the 2 amino acids explained previously, and a type of alcohol called methanol. Methanol consumed goes to the liver, where the liver enzyme alcohol dehydrogenase converts methanol into formaldehyde. Formaldehyde is commonly used in making building materials such as pressed wood products and insulation materials. It is also easily broken down in the air and dissolved in water, so the potential risk of exposure is high to humans. Exposed formaldehyde on skin increases the risk of allergic reactions such as irritation. There are also many controversies as to the effect of chemical exposure in the development of cancer and also leukemia. Methanol is commonly used as an industrial solvent, which is highly flammable and able to mix readily with water and organic liquids. High exposure of methanol by inhalation or ingestion could result in visual disturbances, leading to blindness. Contact of formaldehyde on the skin can cause mild dermatitis. Aspartame compounds are not fully able to be degraded by the environment due to their non-natural origin. Residues of these compounds are discharged into the environment through domestic wastewater, which eventually accumulates and decomposes, producing degradation products with various properties. To conclude, aspartame production has the help of enzyme activity, which is pretty neat. This helps the efficiency of the reaction by maximizing the amount of reactants incorporated into the final product, reduces the use of hazardous chemicals, which for a chemical like aspartame is a pretty big deal. Aspartame is used on such a large scale in commercial foods, so the more green the production, the sweeter for everyone.